Hello guys, welcome back to our channel. So today we would be discussing the latest contest, that is the Codeforces Round 1097, and here I was able to solve A, B and C problems. So I would be giving you the solutions and let's see how we have actually solved this problem. Okay, so let's start with the problem A. So you are given that you are given as an array and you can do A of I equal to A of I plus 1, and you need to find the maximum number of possible positive integers in a finite operation. You can do the operation at most once. So yeah, this was quite an easy problem. So let me give you the idea of how do we have actually solved this problem. So what they have said is we can do actually A of I equal to A of I plus 1, yeah, plus A of I plus 1, right? So and we could do it at most one. So it simply means that either we have an option, either we could or we could not, right? So we can think of it as a DP kind of a thing which we could have. Okay, and if you observe in this particular array, let's suppose if we talk about this particular array, now if we talk about this last array, if this is the last element of this array, does this element have an option to perform this kind of operation? No, right? Because there is no element existing after that, so this particular element would remain the same. Then this particular element would have two options, right? Either to change to this or to remain the same. Okay, now on what condition does this would change to this? It would only change, right, when the updated value is actually greater than the current value. Then only, like, I would saying that it would be an optimal operation, or it would be a good operation for me to perform, right? So in this fashion we would be checking if we got this value, then we would be updating A of I to this, else we would remain it as a current value only, right? And then in the final array we'll check which elements are greater than 0. So this was how the logic was actually is. So if I show you the code as well, let me show you the code. Yeah, so we can have a dry run at a test case as well. Let me show you the code first. So what I've done is I've made a modified array, and I've taken an original array. First I've taken input, and modified arrays remain the same. Now I've started from the back, right? So if modif of I is less than this particular value, right, means the updated value is greater than the current value, then what I've done is I've updated my current to the new updated value, right? And in the final array just simply counted which value is greater than 0, and I've simply printed the count. So this is how our A problem is. I'm sure everyone was able to solve this problem. This was quite an easy problem. Now let's see about the B problem. B problem is also easy. Just we need to do some kind of intuitive work to solve this problem. So in this problem we are given that we need to find the maximum possible value of this particular expression. Okay, and we could rearrange the array. Okay, fine. So let's see. So what they've told us, we are given with an array, we are given with the value, and this is the max A of 1 till A of I, and plus max of A of 1 till A of I, right? So we need to maximize this particular value, rearranging the A's, array A. Now if you look closely, first let me tell you what is the max. What do we mean by a max value? So if I give you an array A is equals to something 0, 1, 2, so max would be 3. If A is 1 and 2, the max would be 0. So max is defined as the lowest positive integer which is not present in the lowest positive integer not present in the array, not present in array. So this is what the max is actually defined as. Now if we now let's like go through the logic of this problem. How do we actually solve this problem? Now this is the prefix max we talk about, right? How do we find the prefix max? So if you give just a small intuition to this problem, you would have come with a solution that if I'm given with an array A and I want to maximize this particular value, right? So it would always be that putting the max element in the front of the array. If I put the max element in the front position of the array, then this value would always be the maximum for all of the prefixes, right? We are able to think of it like that. Let's suppose our array is 1, 2, 4, 5, 2 and 3. Now if I sort this array 1, 2, 2, 3, 4 and 5, this is how our array look like. Now if I make a B array where I'm saying that my maximum element would always, let's say these are like some of the random elements in some of the order, but I have placed the element 5 at the very first of this element B. So when I would be finding this particular answer for the modified array, like the rearranged array, this value for each of the prefix would always be 5, and this could only be the maximum possible value because our array of 5 is the largest element. So we know that we know that to maximize this particular value, I need to put the max element at the front position of the array. Now the question arises is, how do we find the max? So after knowing what do we mean by max is, we can simply thought that I need to do some kind of an ascending operation, right? Ascending order. Like I need to do ascending order, then only I can say find the lowest positive integer which is missing, right? So we come up with an idea that our array B array should be look like greatest element here, greatest element the first, then ascending order, right? Ascending order. Okay, so this is how our modified array should look like. But would this be correct? Would this be correct? Let's discuss with an example. Let's suppose our array A is something like 2, 1, 1, 0 and 0, right? So if we make a B array, so our B array would something look like 2, 0, 0, 1, 1, right? Our max is always 2. Our max is always 2, so we don't need to take care of this. Let's find the max. So if we go and find the max for this, 0, for this would be 1, for this would also be 1, for this it would be 3, and for this it would be 3, right? Now our max here would be 3 plus 3, 6, 7 and 8, right? So this is our summation of max would look like. But now what if I make this something like this, 0, 1, 0 and 1. Let's suppose I'm not taking this B, now I'm taking this B dash over here. So now let's take the array, this particular array, this B dash array which I have taken. Now let's assume this is our modified array, right? Now this is our modified array. Now let's find the max for this. So max till here is 0, max till here is 1, now max till here is 3, till here is also 3, and here also 3. So if we calculate this particular value, so here the max would come as 10. So we would be choosing this particular B dash arrangement. Although the max is same, max would always be 2, but now max here is increased, right? So we would be choosing this B dash array. Now how do we identify that this particular order is the correct order and this order is the not correct order? Like how we can ensure this for each and every B? To identify this, let me give you an intuition. So how about if you think your B array should look like something like greatest element, comma, unique elements, and comma, duplicates, and assuming this is in sorted order, right? Sorted order. Now let me explain you this as well. Unique elements, I mean unique elements by, let's suppose we take this particular example only. So greatest element was 2. Our next remaining elements was, this were the remaining elements, right? So unique elements out of this are 0. So now, so we know that these are the unique elements and this would be the duplicate elements. So this is how our array should, modified array should look like. So once we have found this B modified array, our max would be easily calculated and you can calculate max as well. So let me show you the code as well. So if I show you the code, so if you go through the code, here what I've done is I found the unique and non-unique elements, and if a of I is equal to a of I minus 1, then I will know that it would be a non-unique element, else it would be a unique. Then I've made the array by pushing the unique elements, then pushing the non-unique, and here is a simple code of finding the max. I'm sure you all know that how to find the max, so this is how we find the max in a particular array, prefix max. So this is how our B problem would also be. It was also an easy problem, just you need to visualize this particular kind of setup to solve this problem. Now let's jump to C problem. Let's jump to the C problem. C problem is also an easy problem, like I seems easy, so you can think of, so you're given a regular bracket sequence which turn into okay, so okay of even length, and you choose a sub. Okay, so what they have told us, you are given with A as some kind of a string, and B is also like some kind of a bracket sequence, and B is also some kind of a bracket sequence. So what we'll have to do is we need to tell that if there could be, if there is a possibility so we need to tell if there is a possibility of making this both of them as a regular bracket sequence. So let's take an example also. Let's take this, but so this is actually both are regular bracket sequence, so the answer would be yes. Okay, so let's take this particular example, triple, okay, 4 times this, 2 3 4, then single this, and also then we have, okay, so then we have this. So what they have tell us, this is the A string and this is the B string. Now what we have to tell is whether this could be a yes or this could be a no. Okay, so now we let's if we jump into the logic part, what I have thought is, let's assume this opening brackets contribute a +1 operation and this closing brackets contribute a -1 to our value. Let's assume this particular value. Now for every ith index, if I talk about, if A of I also has the open bracket and B of I also has the open bracket, then I can say this would be contributing as a +2 to my sum, right? And similarly, if they both have the closing bracket, then I can say this would be contributing to -2 of the sum, like they would be decrementing the sum. And if both are different, like one is open, one is closed, then I would making a difference counter, which would be ++, right? Okay. Now, on what conditions can I say my answer would always be false? My answer would always be false. First could be that when my sum is less than 2. When my sum is less than 2, I can say that my like I cannot make a regular bracket sequence, because if we are going in this +2 and -2 side, if my sum is remaining less than 2, then I can simply say that my operation could not be a regular bracket sequence. Or if the difference we are talking about is not divisible by 2, then also we can say, let me show you the conditions as well. So if our sum is negative, then we can say that this cannot be possible, because if that is the case, then we can say that our negative brackets are actually more in number, right? So in that case, I can say the possible would be false. Or there could be a case that my difference is not divisible by 2, right? My difference array is not divisible by 2 and my sum is still less than 2, then also I can say that this could not be possible. Or a simple case, if my sum is not equal to 0, then I can say my possible would be false, right? So if we maintain this particular conditions at the time of calculating the sums, like assuming that this kind of bracket would add a positive sum and this would add a negative sum. So in this way I've thought of to solve this problem, and here is the code of how I've, like, if at any moment my sum becomes negative, then I could simply say that this could not be a regular bracket possible sequence. Or if at any moment my sum becomes less than 2, or my difference and my difference, that the number of positions at which both the brackets are different is also not even, then I can say simply it would be false. And after performing all of these operations, so if to make a regular bracket sequence, to make it a regular bracket sequence, let's suppose this is some kind of a regular bracket sequence of length of even length, then if this sum is not equal to 0, then I could simply say my answer would always be false, because if it's a regular bracket sequence, my sum for above and sum for down should always be equal to 0. So if that is not the case, finally I would simply be false, and it would simply be yes or no. So this is how I was able to solve A and B and C problem. I hope you have liked the video of how do we actually solve the problems, and please do share, like and subscribe the channel for more contest related questions. And also, like, in the shorter span of time I would be starting teaching you the concepts as well of how do we, of particular, like a topic by topic concepts, and then we'll be solving the problem on that as well. So yeah, thank you everyone.